So, good morning. This is Arpad from Index, and we are glad to announce to our event, which is about the software Aragas, software tool for hazardous area classification. And for that purpose, we invited our dear client, Maciej Darnoki from company Webrail, to introduce the software, how he uses, for which applications he already has experience with, and in general, how we can utilize the capabilities of the software.
Hello everyone, I'm Maciej Darnoki, and I'm glad to help you to use Aragas software much more efficiently.
Okay,
so let's start.
Maciej, let us jump into the middle and to see the functionality of Aragas. This is what is a second event. We had another dear client to help us with his experience. So we are really keen to see how you apply, how you utilize the software.
Okay, let's start from the beginning. This is the introduction screen, what you see now in the video. This is how the software starts. From the menu, we can start with the default database, or we can create an own database. In the default database, you will find the most important things, the most important chemicals with properties uploaded. So for the first time, of course, I would like to suggest you to use the default database.
Perfect.
During this introduction, I use also this. Now you see there are several projects that I did previously by this software, and now what I would like to show you how to create a new one. At first, of course, we have to define a new project. There are a lot of things that we can define during this point. First, now I just for the this short presentation, I defined the test project.
Okay, perfect.
With this close button, you can create the new ones. So this is the enter button here. So we are in the test project. Now you see we haven't defined any environment. We haven't defined any source of release yet. So at first we have to define the environment. During this definition, we create a new environment for this now. Just for this short case, we could define an outdoor situation. Of course, we can handle indoor situation also. Here you can find this is a natural or an artificial ventilation here. If you choose the open option, this means we are outdoor. If we choose closed situation, this means we are indoor. Indoor, you can find artificial general ventilation or local or natural. We can create a situation that we are in indoor situation, but the ventilation presented here by natural ventilation.
Okay.
But as we talked before, now we choose the open air situation. We have to define the ventilation speed. Maybe you remember from the IEC 60079-10-1 2015 version, there are a table in the Annex C, the table C.1, which could give some ventilation speeds in outdoor situations. Now we have to choose a material here, a chemical, which could cause the hazardous area. Let's say about hydrogen. So if we choose hydrogen, which is lighter than air, we have to define that our outdoor situation is an obstructed or unobstructed area. Now let's say we are in unobstructed area, just for fun, and our emission source is...
Matej, just one question. Can we say that the software itself strictly following all the points mentioned in the standard?
Yeah. Here we can find unobstructed or obstructed. We can choose the unobstructed now, and we can choose the emission source level from the ground. How many meters are tall? Now we can say it's 1 meter. Here we can find what kind of material that we have got. We said the dangerous material here is hydrogen, which is lighter than air. So the main air velocity is 0.5 meter per second, which is given by the software. The ventilation availability. The availability for outdoor situation is fair, defined by the standard. So we didn't change. No. The ventilation availability is good by the standard. The dilution effectiveness is medium. But by the standard, the ventilation availability is good by the standard. So now...
So we define the environment. Now we are coming to the...
define the environment. We choose the material.
Okay.
There are several material in the software which has already built in, but of course there's a possibility to create a new one, to add or a new material to the software database. You see, we need a lot of the difficult and different properties about the material. So we have to give the figures, the properties of the material, gas diffusion coefficient, and so on, molar mass, and so on. Now we define the environment and the substance. We have to define a source of release. Now in this situation, we choose a junction, a ring type junction connection.
Mm-hmm.
Describe how is it, what is his number or whatever. So we can define precisely the emission source.
Mm-hmm.
Now here we can give what is the state of the physical state of the substance.
Yep.
In this situation, the hydrogen is in gas form. We can overwrite the previously given data, what we typed when we defined the environment. So we can now rewrite the elevation from the ground, or the wind speed, or the obstruction situations. But the software gives it from the environment definitions. We can calculate by fugitive emission if we are indoor situation, and we have got several different kind of emission sources. In this example, I wouldn't like too much speak about it, but it is a possibility which is built in the software. Now, that is the point when we count the grade
of
the emission of the hazardous material. In this list, we can select the kind of the emission. Now we have got only one which we can choose, because for the junction source of release. In the gas state, we can choose only the jet emission. So choose this. But of course, if it would be a liquid, we can choose several different types. We can choose pool evaporation, we can choose jet liquid emission, and we can choose some specific kind of liquid emission when we can give the time of the emission, we can give the quantity of the emission, and so on. Now, this is a simple example for the hydrogen. We can give the grade of the release, which now is a secondary. If we know the emission rate, because our emission source, maybe if it's a safety valve, when the emission grade is given by the manufacturer, we can choose the VG is known option, but in our case the VG is not known. In this case we can give the pressure of the system. The pressure, now what would it be? It would be 200 bar. For example, this junction is after our hydrogen cylinder before the first reductor. If we know, we could give the time of the emission, of course, here. In several cases, maybe we have got some interlock system inside the building near the emission source, which could give an arm and could give an interlock action, close the all cylinder or close the all emission source after a while. So if we know it, we can give it. In some special situation, after we count the fugitive emission, we could give here other numbers of the releases different from one. So if we know that we are in a closed space, we have got 10 or some effective number of the same kind of releases, we can give it. Now we count only with one. Here we can give the discharge coefficient. About this discharge coefficient, the standard said that the typical value is between half and 0.99 in case when we have got a round surface emission, or we have got different from a round surface, a circle surface emission. In our case, this is a wounded surface. So we can give a typical value between half and 75, 0.75. By the standard proposal, now the software is give you the 0.75, but you can modify if you would like. Now we can give the temperature of the substance, the ambient temperature, and the safety factor. In this case, we have got a secondary grade of release. So the safety factor could be given from 0.5 up to 0.9 or 1, if you would like. The 0.5 is the most conservative for the secondary grade of release. So now let's see what we can give from the 0.5 safety factor. The emission source surface can be given by the table which is in the standard or in the Italian guide, which given by the Italian Standard Association. Of course, now here we can use the standard given surfaces. In In our case, it would be a ring type joint connection. Typical value could be 0.1 square millimeter in case of a new investment. Let's say we have got an old investment, but it's maintained well, so it could be 0.25 square millimeters. If you see that there is an old investment, an old factory, without too much maintenance, we could give a bigger number than this. Here we can say about half square millimeter. But in typical situation, we choose this.
0.25, yep.
Yeah. The main air velocity given from the environment definition, what we gave already. Efficiency factor. We are in an outdoor situation, and we said that by the standard that the efficiency is good. So the main efficiency factor is 9. Now let's see what we have got. We have got a jet release. The dilution is medium, given by the standard, but given by the calculation also. And we have got a jet release, which means with this 200 bar over pressure, we got a jet and a diffuse release characteristic, and with this 2 hazardous area number. How we can handle it? We can say this is a typical zone 2 situation because the dilution is medium, the efficiency is good, the availability is good. So we have got a secondary rate of release. This is a zone 2. If we say, okay, let's see zone 2 situation, in this case, the bigger number would be used for the hazardous distance. But we could be more conservative. We could say we have got 2 different numbers. Okay, the standard let us to say it would be a zone 2 situation, but with these 2 numbers, we can use that the first would give us zone 1 number, and the second distance, and the second one is the zone 2 borderline distance. It's our choice to decide which way we use. During the definition of the environment, we said this is an unobstructed area when the availability of the ventilation is good. So we could say, okay, we have got only a zone 2 situation here. Came from the standard table. We don't calculate with this zone 1. And at the end, we can say, okay, the hazardous distance would be 0.5 meter. Okay, we can say 5.5 or 5.1 meter. It depends on us, of course, but the calculation gives us 5.1 meter hazardous distance. After that, we can print it out with an editable format. From the project, we choose the test project, and we can say print it, the ATEX documentation, and we got a Microsoft Word format after a while.
Yes, certainly this is an automated process, so it takes some time. Few questions let me ask. When you have more emission sources with different characteristics, it means you do the hazardous area classification separately for each.
Yes, we can manage the different emission sources separately, but if in case we are in an indoor situation and these different kind of emission sources are close to each other, we can handle them in one project. I will show the difference. For example, for this test project, we give another emission source. What would it be? It's compressor.
And still with hydrogen.
Yes, still with hydrogen. We can choose different materials and different environmental options also within one project. But what I would like to show you that if you choose all different kind of emission source in one project, that the hazardous distance, the hazardous area with this different kind of emission sources has got effect to each other. So if we choose another emission source, for example, a compressor, which could be near this hydrogen cylinder, and we say a jet release, which could be a primary, and the relative pressure would be, for example, 400 bar, because we need this compressor near the cylinder to compromise the 200 bar hydrogen to up to 400 by hydrogen. Why not? These are the same, the emissions, the pressure valve seal. It would be the same. Or sealing elements and moving parts. This would be the pumps and compressors. For example, this would be the, the same. Okay, choose this one. Main air velocity is the same.
Because it's the same environment.
Yeah, the same environment. Would be secondary, just for fun. So now here, we get a bigger hazardous area with an effect to this one. So that's the situation when you have got different type of emission sources near each other.
I do believe the very good advantage of the software that it strictly follows the standards or data given, defined by the standard. But on the other side, it gives you the flexibility to modify parameters according to your application, according to client request, depending on which phase you are.
Yes.
Okay. So I do believe that this is a very instant, experience with the software we made in the last 10 years already. And I really appreciate your time because our intention with all these short videos was to introduce the capabilities of the software. And certainly Aragas is more for gas hazardous environment, but even the dust version exists. And we are working on local language versions. So we already have the Turkish, we will have soon the Hungarian, but Hungarian, Italian already works properly and gives you immediate access to hazardous area compliance. Maciej, thanks for your time and hope to meet you soon. Yep.
Thank you so much. Goodbye.
Thank you. Bye-bye.